Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to use Simatic Manager version 5.6 and how to use the function, it means that FC, to control the frequency of the VFD by using PID control. Okay. In the previous video, we already learned about how to increase or decrease the speed of VFD by using the on-off control to control the speed of the motor screw conveyor. Okay. So today we will continue to create the PID control. Yes. And the concept is, if I would like to set point the weight of the hopper, example 80.5 ton. So if the hopper is less than or greater than 80 tons, it will adjust the speed of the motor by using the analog output that control from the PID to adjust the frequency of the VFD. Okay. So let's go to our software to create the PID control. Yes, let's go. So first open Simatic Manager. Yes. Now we use version 5.6. Okay. And this is the existing project that we already learned in the previous video. Yes. So in the previous video, we already on-off control the VFD. Yes. By adjust speed by manual mode. Okay. So today we will create the PID control. So to create the PID control, we can use the same as the previous video that I already showed. So let's go to create the organization block. Yes. Example OB certified. Yes. And I will use ladder for language. And then go to the open. Yes. And then we can comment for this network. Example create PID control for level hopper. Okay. And then go to library and then go to standard library. Yes. And then go to the PID control block here. And right now I will use PID control for SP5 first. It means that continue control. Yes. So drag and drop the FC48, sorry, 41. Yes. And this one I need to put the dB, right? So example dB 41st. Yes. And then we will create the dB 41st automatically. Yes, here. So here we need to put some parameter, yes, to control. Example, the output, the set point, yes, it means that SP, yes, set point value. So here we need to control, yes. example, we need to manual mode, so we need to put some boolean. Yes, I will put m, example 20.0. Yes, and deselect we can put also, but negative. Example m 20.1. Yes, and we need to put the cycle, right? So example t. Yes, 100 millisecond. Yes, or 1000 millisecond. And the SP we need to put the some address, right, to set point from the HMI. Example MD 30. Yes, and for the output we can put another memory. Yes, that we want, and we need to put the memory. Yes, for output, example MD 40. Yes, okay. So that's all for parameter for PID. Yes, so let's save the project, and then let's go to OB1. Okay, the first I need to delete some existing program that we already learned in the previous video, because it's not related to this section. Yeah, so let me delete. Okay, that's all. I just put only this one because we need to use for scaling. So this is a level of the hopper, right? Okay, level of the hopper. So here is the PV, so I can put the data that link from the DB, right? Link from here. Let me show. Because if we created the PID block and use the DB, we already automatically create this. Okay. So here is the PB, right? So db41.dbd10, right? It is the PV in. Yes. So here I can put db41.dbd10. Okay. Because we need to transfer this PV to control the PID block, right? It means that process variable feedback. Yes. Okay. So that's all. So we can save the project. And then we can download to the PLC. Yes. And one more thing, we can use the feedback from, it means that the output from the PID, right, to control the analog output. And then we can connect the analog output to the VFD, right? So basically I can use MD4T. Yes, it means that output from the PID. So let me online this one first for easy to understand. Yes. Okay, so we can online. So right now the hopper around 54.6 tons. Yeah. So let's go to WinCC Flexible to create the screen for PID, right? Okay, go to the existing project and then go to the hopper. Yes, this is a existing screen that we already learned in the previous video, right? So for start stop the button we still use, right? And the signal of VFD run we also still use. So let's check the text again. So command start, command stop, and VFD run we still use, right? Okay. And for the actual frequency, it should be show on the HMI, right? So we need to create more screen for control. Yes, it means that we can set point or we can monitor the frequency of VFD, right? Okay. So to create the new screen, we need to create the text first, right? So in this case, we need to create some block that related from the PID block, right? So basically, we can add some parameter, yes, or some text that we can link from the PID block. So I will use add one more screen, yes, or here we can add all parameter for control also. I will adjust this one, yes, no need to create the new screen. So I will adjust this one for example set point SV. It is the ton, right? It means that set point, and this process variable PV. It is done also, yes. And this is a parameter. Yes. So we have a set point and feedback, right? And then we have gain for adjust for tune the PID, right? So we have gain. Maybe I will adjust this one to be smaller than here. Okay. Okay, like this. And this is the gain, right? I will copy this one first. It is the gain, and then we have TI, TD, and TM leg. Okay, and then one more, we have output, show the output to the VFD also. It means that percentage that control to the VFD. Yes, so this is the output. Okay, I will copy TI, TD. Okay, I will adjust this one a little bit, small a little bit. Yes, actually we can do the same. Yes, so we can align this one first. Yes, like this. Okay, and we can copy this text to use. Okay, example PV. Yes, we will put the text after we design this one finish. So gain is shorter than, yeah, example 0.5 or something, so it is small. For TI, yes, T integrate, T derivative, this one show okay, like this. Actually everyone can design the style that you want. Yes, here I just example. Maybe I can adjust, align this one a little bit to here, and then move this one. Okay, because we need to put the unit also for this parameter. Okay, so like this. So let me show the project first. So the first one, we need to create the set point value, right? Set point value, this one will be certified. Yeah, this one. MD 30. Yes. So we need to create a new text. So PID SV, it is the real. Yes. So MD 30. Set point PID, right? So set point of PID, and then we need to have feedback, right? So for feedback here, it is the feedback. Sorry, this one is the feedback. Yes. So db41.dbd10, it is the feedback from the hopper. So feedback, or we can write PID PV process variable. Yes, it is the real also. So db1, sorry, db41.dbd10, db41.dbd10. Okay, it is the process variable. Okay, and the next for gain, right? So for gain, it will start from here. Yeah, for easy to understand, I will show this one. Sorry, db41. Yes, gain here. So db41.dbd20, right? It is the gain. So we can add gain. It is the real, right? So db41.dbd20. Okay. PID gain. Yes. And the next we need to create the TI, right? T integrate. So TI, it is the time. Yes. And start from TI here. db31.dbd24. Yes. Here. PID TI. And the next step is the TD, right? So TD, it is the time also, and it will start from dbd41.dbd28. Yes, 28. It is the PID TD. And one more for TM lag, right? Time lag of the deviation action. Yes. So we can input TM lag time also, and it will start from dbd 41.dbd32. Okay, TM lag. Okay, and one more for output, right? Output to frequency. So we not yet create the text for the PLC. So let's save the one first. And for SV, we can input, right? So SV, PID SV, yes. It is the tons. Example 9, it is a format 999.9, yes. Okay, and for PV it is the output, right? So we take output PID PV, and it will show like the SP also .9. And for the gain, yes, PID gain, it is the input also here, and maybe we put like this .9, yes. Okay, I will adjust a little bit for gain. And then TD, right? So TD, it is the time. So PID TD, sorry, TI, it is the input also, and I will put yes, like this, because it is the millisecond. Yeah, so I will put the format for 5 digit. The next for TD, right? So TD, it is the input also, and the format is the 5 digit also, millisecond. And this one also TM LAG, it is the input, 5 digit also. Okay, and for the output we not yet in create the program, right? So not yet create. Okay, so let me save the project first, and then we can put this one, yes, for start and stop is the same, right? So let me simulation, yes. Okay, so let's open the OB1 and then online. So let me check the existing program can use or not. So start, okay, it work. Stop, it stop. Okay, so the next step we need to create the output, right? It means that create the analog output scaling for control from the output the PID to the VFD, right? Okay, so let's start to create. Before start the create the scaling, I would like to show a little bit for formula how to create the scaling of analog. Yes, so it is the output here. Output, it means that input minus input low scale multiplied by output high scale minus output low scale, and then divide by input high scale minus input low scale, and all this one plus by output low scale. Okay, so this is a general formula, and this is a simulation that I just do it, because this formula I got from here. Yes, so example input is 0 to 100%. Yes, and for high input I will set 100, and low output I will set 0. Yes, and this is the maximum of analog output raw data, so I will set high output. So if I set 50% example, it will generate this raw data to control the VFD, right? Okay. So we need to create the scaling, descaling on the formula for easy to convert. Okay. So let's go. Okay, I will save this one first. And then let's go to right click and then insert one more FC. Yes. And this one example scaling. Convert scaling. Yes. And I will choose the ladder language. Okay. So first we need to input the parameter, the same Excel that I show right here. Input, yeah. The input is from the PID, right? Example. So we need to have input low scale, output high scale, output low scale, input high scale. Yes. So we need 4 parameter more, right? So the first one go to input, and then here we can type input, example input. Yes, I will use the integer, right? Yes, and we need to have the 4 parameter more, right? The first one is input high scale. It is the real. Input low scale, low SC means that input low scale. It is the real also. And we have output out high scale, yeah, HSC. It is the real also. And one more for out low SC, it means that out low scale. Yes. And we have output, right? So out or Q, yes, we can write this one. So it is the real, right, for Q. Okay. So we put the same formula, yes, that we already created. Sorry, we must put this one to in. I will delete first. So we have click here, yes, and then here input. So it is integer. So input high scale, input low scale, output high scale, output low scale. Yes, and it is the real. It is the real. It is the real. It is the real also. Okay. Okay, so we need to create the block follow our formula. So the first I will minus between output high scale and output low scale. Okay. So we need to convert from integer to real first, right? So let's go to block. we can integer to double integer, right, here, and then we can use the double integer to real, right? Yes. So this is the input, and this is we need to create the temp. Yes, temp. Example, temp1, temp1. It is the double integer, right? Here is double integer. So the int, it is the temp1, and then we can copy from temp1 to the real, right? So we need to create one more for temporary, temp2, and this is a real, right? Real. So temp2, yes. So for convert, and then we need to create one more network for this. We can command convert from integer to double integer, okay? And we need to create minus between output high scale and output low scale, right? So I will use sub real between input high scale, right? Output high scale. So out high scale and out low scale, okay? And here I need to create a temp 3, and it is the real, right? So here I put temp 3, okay? And then I will subtract also between input high scale and input low scale, yes. So we can use sub real between input high scale and input low scale, okay? And here I will create one more temp 4, yes, and it is the real. So it is the temp 4, yes, okay. And then I will divide this one, yes. So I need to create one more network. So I will use divide real between this one and this one, and I need to create one more temp, right? temp5, and it is the real. So this is a temp5, okay. And then I need to multiply between this one and this one, right? So I can multiply real, yes, between input, at input we can input input minus input low, right? So here I can use sub real. I can use input minus input low, right? Input low scale. So input low scale, and then I will create one more temp, so maybe temp 6. Yes, and it is the real also for data type, so temp 6. Yes, so I will minus between temp 6 and okay, between this one, and then I will create one more for temp 7, and it is the real also, so temp 7. Yes, and the final we need to plus by output low scale, right? So I will create one more network. Yes, so add real. Yes, I will add this one with output low scale, right? So output low scale, and then I will put the output, right, this one, so Q. Okay, that's all for this one. So save the program and then go to the OB1 and then create the new network and use the FC1 that we already created. Yes, so FC1 convert scaling. Yes, drag and drop. Yes, we will got like this. So for the input, right, so input we will got from the PID, right? So I will put this one first, MD40, right? But we need to convert this one first before we can put this block, right? Because it is the integer and this is a real, so we cannot put. So I will add one more network for convert from real to integer. Okay, from real to integer. So I will use round. Yes, I will use round. From MD40, yes, here, and then I will generate for some memory, example MW 70, yes, and I will move, yes, this one to here, MW 70, yes, and for the rank, yes, for input it will reply from PID from 0 to 100%. So here I can put 100% for input, and for low scale 0.0%, and for the output high scale it is the standard of analog output, right? So 27,648.0, and this is 0.0. Okay, so if 100% from MD40, it will show 27,000 for the output, right? And then I will convert from here by using trunk. Yes, because we need convert to the analog output, right? So let me show the analog output hardware. Go to hardware configuration, and then it will start from analog output here, PQW 272, right? So PUW272. Okay, and this one we can put the MD45, yeah, example. Yes. So from output the PID, it will convert, and then it will generate the milliamp or volt to the analog output, right? So okay, save the project, and then we can download. Yes, all. Okay, I will close and then download the whole block to the PLC, right? By select here, and then we can download all. Okay, and we can start. Okay, and then we can online. Okay, okay, like this. So I can use like this, and then open one more block. For PID, right? Okay, like this, and then I can online. Yes, one more block, and then we will create the out, right? So let's go here, go to the text for output. Yes, and then go to this block. So here is the output, right? .36 here, it is the out. So this one is the out. Yes. So we can put db1, sorry, db41.dbd72. Okay, it is the out. So this one output also, and this one the output. Yes. Save the project, and then we can simulation. Yes. Okay. So right now we can set point the level. Yes, this one should be like this. Level hopper, right? So PID PB. It will be like this. Yeah. Okay, so we can simulation again. So right now it show around 54.6 tons. Yeah. So if I set point to example 100 tons, so the output will working, right? So I will adjust this one a little bit. Example, we set point 100 tons. Yes. So the output is not yet so, right? So let me check the data type of the WinCC. Yes. Here is wrong. Yes. So we need to change this one to real. Yes. And then this one we need to change to percent for output here. And this is a percent. Yes. Okay. We can save the project again, and then I will adjust this one a little bit. And for unit, it is the millisecond for here. Yes. TD, TI, it is millisecond also. Okay. So let's simulation again. Yes. So if I set point 100 tons, yes. Let's see output right now show 100% because we not yet adjust the parameter of PID. Example, I set 80 tons. Yes. And for gain, I will set example 0.5 first. And then this one, not sure, right? It is the millisecond. Okay, let's simulation again. Okay. For first, I need to start the motor. Okay, start. And then I will adjust the set point. Yeah, example 80 tons. Yes. And I will adjust again to 0.5. And this one example 2000, it means that 2 millisecond. 2000, it means that 2 sec. I just set first. Yes. So I will show the milliamp. Yes. So right now I set 80 tons, but the actual around 45.6. So if I set 40 tons, it will decrease the milliamp, right? By follow the time that we can set these parameters. Yes. So I will adjust this one to be bigger than this one. Example 3 millisecond. Yes. So I will show how it work. Yes. Okay. So right now I will adjust the uh, input. Yes. To less than the set point. Let's see the output is start increase, right? Follow the time that we set. Yes. Okay. So we can adjust the time. Yes. Example, if we would like to slower than this one, we can decrease the time. Example 9,000. Yes. So it will work slowly. Example, this one I set 0.1 for gain. Yes. And I set this one to 100 tons. Let's see the output is work. And I will show the milliamp output. Yes. So let's see the output is working by follow the time that we set. So if I adjust the PV is greater than SP. Yes. Let's see the milliamp is start decrease. Follow the time that we set. Yes. So we can connect from analog output. Yes. From here to the VFD to control. Yes, the motor. Okay. So this is just example how to create the PID control for control the motor of the hopper by using the Simatic Manager and PLC-based 300. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you in the videos. Bye bye.